My name is Mr. K, and I have a question for you. What would happen if I dropped a tennis ball, a baseball, and a bowling ball on top of watermelons? Let's watch in slow motion to find out.
I bet all of you were a lot more excited to see the bowling ball smash the watermelon compared to the tennis ball or the baseball. Because intuitively, you know that the bowling ball has a lot more kinetic energy, even if the objects are all falling at the same speed. Question is, what's the matter with that? In order to best answer that question, we need to understand the two main types of energy, kinetic energy and potential energy. Kinetic energy is the energy of the motion of objects. Simply put, the faster an object is moving, the more kinetic energy it has. While the speed of an object is a major contributing factor to its total kinetic energy, the object's mass, or how heavy the object is, also plays a significant role. Let's pretend for a moment that you're this watermelon. Would you rather that a pitcher throw this tennis ball at you, a very light mass, or this baseball at you, a very heavy mass? Oof, that's gotta hurt. That's why it's important to always wear your helmet. Let's move on to our second basic type of energy, which is called potential energy. Potential energy is the measure of how much energy an object has based off the object's position. There's a lot of different types of potential energy, so for this video, we're gonna focus on gravitational potential energy, which measures how much energy an object has stored based off its height above the ground. You can imagine holding the bowling ball just above the watermelon, and if I dropped it here, it might leave a little dent, but overall, the watermelon would be fine. Now imagine that I stand up and we've increased the potential energy of the ball by lifting it up above my shoulders. Now imagine if I were to drop the ball now, how much damage it might do to the watermelon. With the mass and the increased potential energy, it'll do more. But what happens if we go higher? We can increase the bowling ball's potential energy even more if we climb them up to the top of the ladder. That way, when we drop the bowling ball from up here, we should see a lot of damage. You know, I just had a question pop into my head. If I got a heavier bowling ball, would that make the bowling ball fall faster? Or would it fall slower? Well, here is a great lab investigation that should help us answer the question, how does the mass of an object affect the rate that it falls due to gravity? The supplies are really simple for this one, and you have just 3 objects that you'll need to be dropping that are of similar size, but of different weights. Teachers, you can see the lab investigation here. If you want to make any edits to suit your needs, please go ahead and hit File, make a copy, and you're free to use it however you want. Just be sure that once you guys are done with your investigation, that you come back to this video so we can see that watermelon get smashed. I hope you found that lab investigation really fun and that you learned something new. In case you haven't seen it, I'll put a link down in the description and a card up here to a video where scientists took a bowling ball and a feather and dropped them at the same height in a giant vacuum chamber. A vacuum chamber allows them to take all the air out of it, so when they fall, there's no air resistance. The results are surprising. Throughout this video, we've been talking about potential energy and kinetic energy and how they can transfer between one another. That has me wondering, is there any real-world applications to this? So now that we know that to get more kinetic energy out of this bowling ball, we simply need to add more potential energy before we drop it, we know how to best smash the watermelon down below. So let's go ahead and do that. You know, if adding more potential energy gives me more kinetic energy, what would happen if I dropped this bowling ball off of a roof? Now this is more like it. Now that we've increased the bowling ball's potential energy by increasing its height above the ground, now when we drop it on the watermelon, it's gonna have a lot more kinetic energy. Three, two, one. I really appreciate this watermelon. Just like you now really appreciate potential and kinetic energy. Let me leave you with this question. What are some ways that you could reduce the amount of energy impacting this watermelon when the bowling ball hits it? I'm Mr. K, and this is the matter with potential and kinetic energy. See you in the next video. Oh, you're still here? You must really want to learn more about potential and kinetic energy. I'll put a link, hide it down at the bottom of the description. This really cool lab simulation that you can do that shows potential and kinetic energy. All right, get out of here.